This. I am Carl Moberg. I am the CTO at Avassa, and this is Fredrik Jansson, who is a solution architect and who will do the demo. Now we're going to talk about something that I'm not going to sing through it. I'm just going to say, staying alive. How to manage applications in offline edge scenarios. This is truly one of the key, if you like, tailwinds for edge computing in our mind. Companies that have business critical applications that needs to run close to the source of data and needs to survive upstream outages. I will also say that we're Avassa, and what we provide is an application management operations platform for on-site edge environments. We help customers manage both the infrastructure, but also the applications outside of the cloud. That's usually what they mean by edge, on distributed infrastructure in an automated, secure, and scalable fashion. And by on-site edge, like we have on the illustration here, we mean locations where the enterprises have a small number of computers, a small amount of compute, to support applications that they need, again, to run close to the physical edge, if you like, close to data sources and users. And of course, this is a common pattern across a couple of verticals that we find interesting. Retail, computers in stores, of course, industrial manufacturing, a lot of things happening on the factory floors, and also environments like marine environments where the ships themselves are becoming thoroughly digitalized for many reasons. So let's start this by looking at what a typical 3-node cluster looks like. So we're going to talk about resiliency here. So let's look at a 3-node cluster, which we happen to have here today. What we've set up here, of course, is an environment that needs to be resilient, if you like, in two ways. Right? It needs to be resilient both in terms of a local cluster, so you get failover, but also it needs to be able to support prolonged upstream outages, right? So you need to be sure that you can keep your applications alive even if you have an outage. So in order to demonstrate that, I will provoke one of those with a scissor. So here's the upstream connectivity from this cluster here. So let's do a demo like this. Whoops. All right. Because there's always that guy. And just like him, I was sure that cable didn't actually impact my ability to present here. So we didn't understand that was a problem. And to be fair, as you can imagine, the reasons we see this is more varied and maybe less humoristic for the poor people that need to take care of it. So what actually happened here is that the site that we have here is now fully and physically offline. And the cluster nodes and all the applications residing on them are now unable to reach anything outside, of course, the local cluster. And in order to build an architecture like we do to support this kind of common outage, we have to step back and look at the moving parts, right? Because a lot of interesting things I happen to think happen here. If we just step back at one moment and say, again, the challenge is that the applications are kept whole and running and delivering whatever business value that they are expected to. If we start with the cloud domain, of course, everybody knows that you run stuff at the cloud, people at the periphery will reach that. But everyone who's actually built or running applications in the cloud knows that there's more to it. There's usually a slew of services that you need in place in order for a modern application, a cloud application, to actually perform well. And this actually is becoming a pretty crazy amount, driven by the thank you. Microservices architecture, where you kind of put some fundamental features that used to be inside of an application outside. So you have things like name resolution, event streaming services, secrets management, and application failover, right? So these are things that applications require close to them or reachable for them to actually run well, or even run in some environments. And if we look at the edge, of course, we have to do the same thing, right? In order for modern applications that adheres or sticks to something that looks like a microservices architecture, they require all these ephemeral services in a location that's protected by the blast radius concept, right? So if you cut your upstream, you can't know that you, for example, can restart a container if the requirement is that you have a container image repo, like a Docker Hub, for example. Same thing for name resolution, secrets management, multi-tenancy, logging aspects, right? So all these things need to actually run at the edge in order for this to kind of keep your application alive. With all this in place, so let's switch to a demo. Okay. So again, the demo here is that we are a very large energy corporation. A site was disconnected from the centralized cloud, but our great infrastructure team, i.e. Fredrik here, has made sure that we have all the supporting services for actually allowing applications to survive uninterrupted in place. So the authentication service that we have here that is really critical to the operations of the local site is uninterrupted. And eventually, of course, we will make sure that the upstream connectivity is restored and they can go work on the post-mortem, and I will never be able to own a pair of scissors anymore. So let me just really briefly show you quickly here that.
Okay, so as Carl proved then, this cluster is now offline. It doesn't have any internet connectivity. And of course, it's important to the very large energy corporation that the services that they have deployed at this particular Santa Clara site is up and running. So again, I'm gonna choose one of these. I'm gonna log in here, and as you can see, the service is still there. Here, I hope, and it turns out that for our customers, they almost always have applications that they run locally. And then in case of something like this is happening, there may be certain actions they need to do at the site. So not everything is automatically managed when they lose internet connectivity. We have seen, for example, point of sale players that are like cloud first, but in case of they lose the connection in the store, they're gonna reroute their cash registers, I guess, to some server that is actually running in the store. So they're moving from cloud first to edge backup. And to cater for that, they typically have a number of things that they need to do in their application. So this is jokingly just showing that when they build applications like these, there are certain things that are particular to their application, like blow all the fuses. Please don't do that, but or disconnect net flanders. These are obviously things regarding the energy corporation. But Avassa also provides, as part of our service, APIs that are local to the cluster that you can actually utilize from your application. Everything from what I show here, which is basically showing just where my applications are running, so on which machine they're actually running, and it monitors that they are up and running. It tells me what IP addresses they are running at, and so forth, just to show you some integration with our APIs.
So which host is the authentication application running on?
So that's running on Santa Clara 1. That would be this guy.
Yeah, let's do this guy.
Are you gonna?
Yeah. Okay.
Okay.
See what happens now?
Kill that host?
Yeah, I did.
Okay.
Yeah.
You didn't use scissors this time. I noticed you were much more respectful.
Yes.
But your partner's
it's partner hardware.
Well, I guess we told you guys that we do everything we can to keep applications up and running. So hopefully now, if I refresh this, I was probably on that guy, so I'm gonna log in on. This is why I set up 3 instances of the other one. Give it a sec here. Oh, here we go. So all this tries to prove is that we're actually starting up the application again, the authentication service, but now on a new host, Santa Clara 3, one of the NUCs back here. So the system does this automatically, and as Carl said, to be able to do this, it actually needs a number of things. It obviously needs the container images replicated among the machines. It needs the configuration to be able to start that application again, replicated. Any secrets, certificates, credentials, and so forth also needs to be replicated, because we want to make sure that we, at instances like this, no internet connectivity, one of the hosts goes down, we need to make sure we have everything we need to restart an application on a new host. So this guy should be coming up here. Yeah, it's up and running. It's still complaining about the grid controller, obviously, because I told it I wanted to run one per host, and one of the hosts are gone. So that is kind of in an error state. But hopefully that shows you or give you an idea of how our offline capabilities work, even in case of someone puts the power.
Yeah.
So even for your Keycloak-based version of this application, is that actual container stateless? You're storing the information in it somewhere completely and totally else?
Correct.
Yes.
Okay,
Exactly.
but there's going to be a period of time from when you convert that VM over and you've got it there,
Yes.
Yes.
and Boomer Bob converts it to being, to Keycloak.
Yes.
New users going to get created, new groups, new permissions, all that fun stuff. How are you protecting those workloads other than making them available? Because if it's in reality months instead of like hours,
Yes.
and things change, and you just deploy the that
Yes.
container again,
Yeah.
that image, well, now you've lost everything. Where's that middle ground?
There's a whole can of worms. That could be its entire, I'm not kidding, part of a session like this, because it means that the world has changed. You're offline, you come up online, and you want to make peace with whatever happened up. And there's two ways to think about this generally, and this kind of almost devolves into a computer science problem. Who's right? Right. So most of our users would say whatever is here is now true, and we'll just write over whatever's on the edge. Now, in marine environments, for example, there are regulations that says the opposite. You have to be able to do changes at the ship, and then actually conflict resolve. So there are generally two ways of doing it, and it's mostly up to our customers to choose.
Right, but I mean, you still have a Windows VM that's running and sitting there, and most likely it's not going to be somebody comes along and snips your Ethernet cable.
Right.
It's going to be a ransomware event.
Yeah.
In
But our
today's day and age. Again, how are you protecting those workloads?
Yeah.
So you actually have a backup capability that's not.
So they solve it in different ways. Some of them would not run a single authentication service. They would actually run that in multiple replicas and have replication among them. So they solve it on the application layer. Another option would be to have some kind of shared storage, what you say, which would probably be needed for a virtual machine.
Right.
They are not easily replicated as an application.
But effectively, at this point, I guess what I'm getting at is, do you have a backup capability that's integrated into your system that lets you protect those workloads and ship copies off somewhere else?
So we stand on shoulders of giants. That comes for free. Most of that comes for free from container runtimes and volumes.
Okay.
Yeah.
Again, we want to see that extended to the Boomer Bob's Windows machine as well. Be able to extract out the changing data and be able to just re-provision.
Yeah.
Yeah, in some ways, it seems to me you're striking I was going to say balance. Balance is the wrong word, but the conflict really between old development model and new development model. I feel like you are speaking to very much in the age-old conflict between the developers and the infrastructure folks. You're very much speaking to the developer side, trying to give them more tools and capability and control. Containerization is, a classic way to do this, but that seems to be your posture: provide choice and ability for the software designer and developer. Is that right?
That is a very nice way of saying it, but here's what happens, and this happens in every conversation. The infrastructure teams normally now feels the pressure to do better for the application teams. So honestly, our target persona, if you like, is the infrastructure team, but mostly infrastructure teams that are well incentivized, internal or external, to do better in serving the application teams with tools that they can love. I mean, that's the long and short of it.
Yeah, if they're not recidivists, then they want to make progress. And so this is giving them a way to offer something to their application partners.
Exactly.
Yeah.
Exactly. And it's such an interesting topic. And in certain verticals, like in retail, it is also the application teams, right? So instead of a store, some of our users have like 12 application teams. Some of them wants the IT or the infrastructure group to do it for them. Some of them are even outside the organization. So they're running third-party software inside of their stores. So you're very right that we are aiming for a world where that separation of interest is important. Some of them actually have both in the same team. Some of them have them with organizational distance. But you're bang on, absolutely.
Is Avassa offering services or partnerships or of the like to help enable that transition? Because another thing that occurred to me is that there's a lot about this that seems more recode oriented than even refactoring oriented, but that's a significant hurdle for a lot of organizations to overcome. So are you just essentially agnostic about that, ensuring, as you put it, perpetual VM use, if that's what or are you in any way through your own services or partnerships or service providers, are you and helping with that transition as well?
We're a fairly small company, so if it's a small distance between they are now and some sort of decisive moment, will help. Otherwise, we have partners for it.
Yeah.
Because it's usually actually a bigger
I would expect you to use partners. I think partners is the best way to do it.
Absolutely.
Yeah, I wanted to ask my question agnostically.
Question about the offline operations that we saw. Is that available for some bespoke hardware? Let's say I have GPUs or something like that in the hardware. I can have those offline operations, use those other resources depending on the node. I'm assuming that's agnostic, right?
Yeah,
Yes.
absolutely.
There's a ton of details here.
Yeah.
Because also the inter-host scheduling. I mean, you may actually kill the only host that has a GPU.
Yeah.
Right.
So the application that requires a GPU actually have nowhere to go.
Yeah.
It gets a little complex.
Presumably, you could address some of that by your rules around which site you deploy an application to, and say if it's not a fault-tolerant site, we're not deploying it.
Exactly.
Depending upon business criticality of the application. Yeah, I noticed only one VM host at the site, so it's a good thing we migrated to a native authentication.
Are there any use cases or situations where you're not a good fit?
Oof. The inner me wants to say no now, but I know how that sounds. I will say that things where we can't help is okay. I got one. I got a way of saying it. We focus heavily on the people that rely or wants to lean heavily on containers. If containers is not important, so they want to run native applications, just start and stop applications on Linux, and more exotic operating systems, right? Or hardware platforms that are so small that it actually doesn't make sense to run a container. You should run some sort of binary. So let's say there are resource boundaries where we start making less sense. We have users using us for cloud-hosted VMs, but that is also where it starts becoming a little weird. Good for them, but it becomes a little weird. So maybe that's a way of saying it. There are boundaries to the exotic hardware and software environment, and there's usually less reason to run us for cloud-hosted, purely public cloud-hosted applications.
Can I also add? I mean, if you have like 2 data centers where you want to run your application, we are probably an overkill for that. If you build an application and you never change it, you never make any changes to your application, you don't have a version 1.1 and 1.2 and so forth with a reasonable cadence, I would say that is also, we will be overkill for deploying an application once and let it sit there for 10 years.
But what about your backup capabilities or your...
Sure.
Can't you still use that for that? Wouldn't that be an advantage?
Yeah, I mean, we can use it for, one of the, again, I keep being surprised how important day 2 operations and security is, rather than the kind of us front-loading some of these presentations with the deployment and update magic. So just the monitoring and health and what's called observability, we didn't show too much of that. You can drill in and look at the logs, and you can actually log into the container and all that kind of stuff is important, even though you may not update the applications.
Yeah.
Fair.
And configuration management, secrets management. So there are kind of ephemeral features as well.
Yeah. Thank you.
We really, again, people talk about the fact that ping times or response times, kind of traditionally, at least in the press, has been the reason for edge computing. We see that actually offline scenarios is way more important for the customer base that we have. Being able to survive upstream outages, planned like in marine or unplanned like in retail, is really key. So designing the infrastructure for that seems good. Seems like a good thing. And with that, what you're going to drag with you is the operational insight that applications require a lot of services these days to function well. As I mentioned, deploying an application to the edge while assuming that your event logging, endpoint, which is central somewhere on the internet, is not a good idea, because when that connection goes down, you're going to lose out on your audit trails, your logs, everything. So think of that, and keeping the service local, including kind of basic infrastructure services like the one we showed you, which is failover between hosts, even in outage scenarios, kind of driving towards let's call it a dual control plane. One is between the central, in this case, control tower and the edge. The other one is local to the site. And have them work independently is really key to provide this kind of robustness.